Here again, Martin Lechner, CTO of Wikitude and chair of ARML 2.0 standards working group within the OGC. I'm here to talk a little bit about ARML 2.0 and what this is all about, where we stand, and what the next steps are. This is what ARML 2.0 is all about. We kind of a little bit of history on ARML and why this is called ARML 2.0. Basically, ARML 1.0 was a proprietary format that we, as Wikitude, developed back in 2009 for our augmented reality browser. It's not related to ARML 2.0 except for the name. And ARML 2.0 is not backwards compatible with ARML 1.0, so that's really two different things here. Well, basically, ARML 2.0. ARML is a diverse, AR is a diverse field. That's why we all here. I mean, very different industries, different topics come together. It's kind of a mashup of various technologies. So when you talk about standards, as you see, you have to somehow limit your scope. And this is what we wanted to focus on. Basically, we wanted to allow a developer who wants to basically describing augmented reality scenes, the objects, where they are in the scene, how they behave, and we wanted to focus that on mobile visual AR. So mobile means that you're on a mobile device. Well, you say. Doesn't necessarily have to be a smartphone, might be a tablet or whatever, but most likely will be some kind of these devices. Visual AR means that we use the camera, or the screen of the device as the main output screen. So we do not particularly focus on something like haptics or audio-based AR in ARML 2.0. We might consider that in the future, but right now this is really focused on mobile visual AR. We're building a one object model, but we have two different serializations of this object model. Basically, we have a descriptive format, which has a serialization in XML. So you describe a scene in XML, and then you can add scripting components, which basically allow you to interact with these objects. It's kind of the same way as HTML and JavaScript interact. With HTML, you describe the web page, and with JavaScript, you kind of describe the interaction and what you can do with it. And we reused that concept for ARML. A couple of facts for ARML 2.0 and the standards working group behind that. We have actually 55 participants as of today because during the Mobile World Congress, 2 additional members joined. We started in Boulder at the regular OGC technical committee meeting in Boulder in September 2011. Right now, ARML 2.0 is an improved OGC candidate standard. It went through the OGC process. That's where we are so far. We had a public commenting phase, which was running from November to December 2012, last year. And the public comments have recently been incorporated into the specification. So if one of you guys have commented on the specification previously, then you will see the comments reflected in the spec, or at least an email saying why we probably did not consider it. We have a couple of browser vendors, AR browser vendors, ourselves, Georgia Tech, which are developing the Argon browser, and we have a couple of other people who got their hands dirty in augmented reality, and also, basically, augmented reality content developers. So we all help together to develop ARML 2.0. This is kind of, the ARML 2.0 overview. If I had to summarize augmented reality markup language 2.0 in one slide, this is probably the slide that I will put up. So we have 3 different main concepts in ARML 2.0. We have a feature which has anchors, which then again have visual assets or assets. So basically the feature is, as George was already mentioning, it's kind of the real world thing that you actually want to augment. So like whatever, the Eiffel Tower, for example. So it's really the physical thing in the real world. That's called a feature. That feature has anchors in the real world. An anchor means either geospatial location for geospatial AR, or something that you actually want to track in your camera screen, like this marker or whatever reference image you have which you want to overlay. So these are the anchors in the real world, and these anchors have visual assets. The digital objects that are actually presented in the scene. For example, a 3D model of the Eiffel Tower, or image, or text, or what have you. Whatever you want to augment on top of that. We have several types of anchors that are currently supported in ARML 2.0. I mentioned a couple of them already. Spatial anchors, basically a position in, well, somewhere on the Earth. And George was already mentioning that WGS84 might not be sufficient for all the AR scenarios, especially when AR moves into indoor scenarios. So we do not restrict the coordinate reference system to WGS84. You can also use various types of coordinate reference systems, whatever you want to specify. We're using GML, which already does a good job in describing these things or allowing the description of various coordinate reference systems. So we are making good use of existing standards here. Then we have the trackables. I was already mentioning that. We have markers or reference images or whatever, the things that are tracked in the camera screen. Relative to is another type of anchor. Sometimes you have scenarios where a particular thing like a marker shouldn't be overlaid like immediately. It should kind of describe an augmented reality scene or trigger a richer experience. For example, here it's just a very basic example. This marker here basically outlines the entire table. So not just the marker is overlaid, the marker is kind of describing a locate or allowing a marker allows the description of relative locations. For example, the location of this table, or you could place objects relative to this marker. So this is what a relative to location is all about. And then a fourth type is on-screen, or a screen anchor, as we call it. Basically means that this is not registered in the real world, but statically positioned on the screen. So allows for heads-up displays, for like game statistics and whatever you have. A kind of a deep dive into the trackable, because I was already mentioning that for a trackable, these things that you're actually tracking in the camera stream, that thing must be very generic, because we have various scenarios in augmented reality, things that you want to track. It's not just markers, it's not just any reference images, but probably you want to have 3D tracking or face tracking, sound tracking, infrared tracking. Well, so a tracker is kind of the description of how you should track that trackable. What component should you use to track that? And so you can describe both things separate from each other. You could, for example, use a kind of here a face tracker, as you see on the bottom right corner of that screen, where the face tracking solution, which is actually available on your device, is the tracker, and the face itself is the trackable. And then coming back to the visual assets that actually support in ARML, we do have 5 types so far, and of course this is open for extension in the future, whatever is required by the community. These are the 5 types that we support. 3D models, we do not restrict it to a particular type, but we should suggest the Collada file format in the first place for several reasons. We have images, 2D representations, of course. We have something that's called fill, so you want to fill kind of a polygon or a line with color or whatever, so kind of a simple representation. Labels allow you to use any kind of HTML content and put it up as a 2D billboard or whatever. And simple text. So these are the 5 types that are supported for visual assets, the things that I actually presented on the screen. What you can do with visual assets after you have actually you've described it, is that you can apply various transformations on it. You can rotate it, you can or basically orient it. You can say, this is the location of the visual asset, and then it can either be absolutely oriented in the 3-dimensional space, facing a particular direction, or it can always face the user, which is kind of a good scenario, especially for augmented reality browsers, for example, when you have 2D text, which should always face the user, regardless of how what direction you're looking at. A basic document outline, how ARML files will look like. This is what you do. You describe the AR elements in XML. As I said, we have the XML encoding here. And then we have the script type and the style type. So again, kind of similar to HTML elements. The scripting type allows you to describe the behavior, and the style type obviously allows you to style the visual assets. And one last thing that I want to talk about is the events that you can actually describe or you can react to as soon as, for example, user click on visual assets or touch them, or start spinning around, move, for example. All these events you can react to make your augmented reality scene interactive. And so these are this is just an outline of the events that you can actually use. For example, as I mentioned, clicks, or when visual assets actually come into the field of vision or exit your field of vision on the camera, you can react to that. You can do whatever you want, and all of that is described in JavaScript. Again, similar to HTML and JavaScript working together. It's a very similar concept to what we had previously.